Welcome to the first video of GitHub Action series. In this video, we will be covering about GitHub Action Security, threat landscape, and basics of GitHub Action Security. We will be covering topics like CI/CD attack surface, common CI/CD attacks, credential leakage, malicious PR, dependency confusion, runtime compromise, shared versus self-hosted runners. In the demo, we will be also covering about a sample GitHub Actions workflow, which is an insecure workflow, and then we will see how secrets can be leaked via logs in GitHub Actions. Let's get started. I have documented the complete video series in GitHub Actions security series repository in my GitHub repo, and this will be available for use after the video. So let's get started. Let's talk about the attack surface. The attack surface is the common areas where the attackers usually target to get into the system via CI/CD pipeline. The common components are secrets. The secrets are the places which is at a very high risk, and it's the most critical component of a system. Secrets store various keys, cloud credentials, database passwords, because of which the attackers intend to target secret first. The second component is triggers. So attackers usually create a trigger from outside your code so that they can push some malicious code inside your code and then they can get into the system. Third component is dependencies. So usually a code uses various dependencies, and these dependencies are third-party dependencies. So attacker usually try to create dependency with the same version so that dependencies get pulled while the build is happening using the CI/CD GitHub Actions pipeline, and then they can put some malicious code uh, inside your code. So, and the last option is the runner environment. So this is the environment where GitHub Actions pipeline actually run. So if the environment is insecure, the attackers get access to those environments. They can get access to your secrets, they can get access to your code, and they can get access to different infra components if it is accessible from that particular environment where the GitHub Actions pipeline is running. Now let's talk about some of the common CI/CD attack surface. The first one is credential leakage. This is the most common attack, and developers accidentally print secrets to the console during debugging. So whenever the GitHub action pipeline is triggered, if it fails, usually what a DevOps or a developer does is they try to put some logs to identify that, okay, if the secrets and the variables are getting fetched clearly from the settings of GitHub where it is actually stored. So GitHub actually tries to mask those secrets using asterisk, but there are ways where developers can make mistake or DevOps engineer can make mistakes, and those credentials could get printed in the logs, and then that would be exposed to the external world. Coming back to the second common CI/CD attack, this is the PR. So what attacker does is attacker forks the GitHub repository. They submit the GitHub action workflow PR in which they tries to steal the secret. They try to submit a PR where they can insert some malicious code, or they can probably say put some cron job or a file which get triggers when the CI/CD workflow starts next time. So this usually happens in the combination of self-hosted runners. So that is the reason pull request is considered as malicious whenever it tries to do some unintended activity. The third part is dependency confusion. So attackers try to publish a malicious packet into public repository with the same name which is being used into your code, and then what it does is the runner isn't configured correctly, so it is not using the hash code. Suppose it is using a version v1. At that time, it is going to download a malicious code from the public repository, which is actually not safe, and then unintended code gets entered into your system using the CI/CD pipeline. And the fourth common CI/CD attack is the runner compromise. This is a shared runner and a self-hosted runner. So there are two types of runner in GitHub Actions pipeline. The shared runners are hosted by GitHub and they're ephemeral. They are deleted after the use, and that is the reason they are considered as safe. And also patching and the updates and what kind of container uh, is being used, or the latest availability of container is in hands of GitHub, which is not usually taken care by you. So That is the reason it is considered safe when compared to self-hosted runner. So self-hosted runners are those where the server on which the pipeline will run will be managed by you, and if the attacker gains access to that pipeline, he can persist some code. Maybe attacker can put a shell script next time when the GitHub actions start, that shell scripts get executed and perform an unintended activity. That is the reason, like GitHub runners are safe compared to the self-hosted runners. Coming to the demo part, we will covering this in the next video, in which I'll show you how an insecure workflow can lead to the printing of credentials into the GitHub Actions logs. And then the second thing which I'll show you is that, okay, there is another way where you can expose the secrets by printing those into a particular file and then committing that file. And the last one is uh, which we discuss is like a PR can be raised to a fork repositories, and then unintended changes can be done to the pipeline, which can result in leaking of the secret. But this we will cover in great detail in one of the upcoming lectures, and this will be part of a different episode. Thanks for watching.